welcome back students. Now we have already completed the 2015-2016 paper as well as 16 and 17 paper. Right, now I thought I'll do certain questions which are based on graphical representation. Done. So graphical representation questions are compulsory in your paper. So I felt I'll be doing very important questions which are related to the graph. Done. This will be including all the chapters. So all the chapters wherever there is graph given, either it is in organic or it is in inorganic or it is in physical, I'll be dealing with the graphical representation questions. Hope these are very useful for you all. So this will be named as a graph arcade for both the IIT, JEE as well as NEET students. So go through it. Very simple. I'll try to make it easier and explain it to you. Now what do they give us? So there's one graph given for us in the question paper. Let's read this. A weighed sample of a metal is added to liquid bromine. Okay, a sample is weighed itself and it's added to liquid bromine and allowed to react completely. Okay, done. The product is then separated from any leftover reactants and weighed. Okay, they both have reacted and a product is removed, they have weighed it separately. The experiment is repeated with several masses. So several masses of the metal is given, 1 gram, 1.5 gram, 2 grams, 2.5, and mass of the compound also formed also is given. Done. The experiment is repeated with several masses of the metals but with the same volume of bromine. So bromine volume is maintained standard but the metal is varying, right? Okay, and the product formed also they have given, right? So but let me read again. The experiment is repeated with several masses of the metals, okay, but with the same volume of bromine, and results are being plotted. Done. If the 20 grams of each metal and bromine are allowed to react, the approximate weight of the compound will be very easiest question, but question is a much bigger, but solution is very easy. So what should I find out? I need to find out if 20 grams of bromine reacts. They said bromine is standard, but now they say 20 grams of bromine if it reacts, the standard value, if it reacts, how much is the amount of the compound formed, they asked me. So from the graph, let us see. On the x-axis they've given us the mass of the metal, right? On the y-axis they've given us mass of the compound. So from the graph, what can you just observe? They've marked a point here. Then let us see according to that. So first of all, from the graph, if I have to see from the graph, what can be concluded, right? Most like 1.5, most of 1.5 grams of the metal it combines, right? It is concluded that 1.5 grams of the metal has combined with the bromine to form this compound. Okay, right? So 1.5 grams of the metal, if I have to say, because it is marked here, so 1.5 gram of metal has combined with how much of bromine? If I have to say, 19.5 grams. If I have to say 9.5 grams, 9.5 grams of 1.5 grams of the metal with 9.5 grams of bromine standard. How did I say it is 9.5? Because when I have to see, the total mass of the compound is 11. See here, 11. Right, that means the 1.5 grams and the bromine combined together has given you a compound, because that is marked as 11. So mass of the compound 9.5 for 1.5 comes to 11 grams. Done. Yes. Now next important thing, what did they ask me? Now when I see both the things, which is a limiting reagent? Bromine is a limiting reagent here. Bromine is a limiting reagent. Correct? Yes. So when bromine is a limiting reagent, next what should I find out? I need to find out how much amount of compound is formed when 20 grams of bromine is reacted. So simple. I'll just do this step. This is easy for me. 11 grams of compound, as I have seen, 11 grams of compound. How much was the bromine? This is metal, but how much was bromine? 11 grams of compound. How much of bromine? 9.5 grams of bromine reacted. Correct? Now how much for bromine they've asked us? 20 grams of bromine. 20 grams of bromine reacts with how much? So if I have to calculate 11 into 20 by 9.5, which is equal to 23.15 grams. That's it. So the correct option here given to us is 23.5. Hope you have understood this. Now I've taken this. This is the main step here, because why did I take this? I need to relate with 20 grams of bromine. That's why I did this step. Let us come back and do the next question in graphic. right? So next thing, what they give me, they've given me identify the correct graph between fraction of radioactive isotopes, okay, remaining, that is y-axis, versus time. Okay, let us read this question again. What is this one? I need to find a correct graph between fraction of radioactive isotope. Okay, fraction n by n naught is given to me, remaining that is, which is taken on the y-axis, versus time. So everywhere time is given. So first of all, whenever such question is given to you, radioactive decay of isotope, radioisotope, the fraction of radioactive isotope remaining, the form, there's one formula, important thing you have to remember. What is that formula? So I'm writing the solution. Remember this: for fraction of radioactive isotope remaining, how much is radioactive isotope? What is the fraction? N by n naught. This n by n naught, the formula is equal to e raised to lambda t. Okay, what is lambda? Lambda is a decay constant. So what can you say from this? N by n naught is equal to minus t, base e raised to minus t. So what is the graph which is relating? Not this one, not this is not the thing, not this is not the thing. This is the correct graph, isn't it? Because n by n naught is equal to minus t. So this by n by n naught the minus t of that. So the correct option is, if I take this as A, if I take this as B, if I take this as C, if I take this as D, the correct option is A according to this formula. So remember that fraction of radioactive isotope remaining is equal to base E raised to minus lambda t. Simplest question, isn't it? Let us do one more. So in question 3, one more graphical representation question is given to you. Let us read this question. Which of the following graph correctly illustrates the dependence of cell voltage E cell on pH of the reaction? Correct. They've given one cell reaction, that is silver, that is 2Ag plus hydrogen gas gives me 2Ag plus 2H plus aqueous. Okay, they've given one cell reaction. What do they say? Which of the following graph illustrates or explains the dependence of cell voltage, that is relation between E cell and pH of the reaction? So they've plotted different graphs between E cell and pH. They've obtained different results here. This is one result, this is one result, this is one result, this is one result. Assume that the silver ion concentration remains constant at Ag plus, which is equal to 1 molar, and hydrogen pressure remains constant at 1 atmosphere. So they've given this graph, right? So first of all, when such graph is given to you, you should know the relationship between E cell as well as pH of the solution. Remember that. So the first thumb rule you have to remember, the first logic is E cell is directly proportional to pH of the solution. Remember this, directly proportional to pH of the solution. So what is the concept here? E cell is directly proportional means which graph explains this one, which is increasing here, decreasing? Wrong. This one? No. When I see for E cell is 0, this certain value for this, wrong, isn't it? So this is the graph which explains E cell is directly proportional to pH of the solution. So the correct answer for this is A. This is the concept. So remember this graph. Let us come back and do one more question. So in the next question, the following figure shows the fraction of 4 fractions of tribasic acid. Okay, there is a tribasic acid, 4 fractions are shown here, right? Which line represents A minus 3? Okay, very interesting question. What do they give us? They've given us 1, 2, 3 ABCD fractions. Which line? Whether this one represents A minus 3, or this one represents A minus 3, or this one represents A minus 3. So when such things are given to you, first of all, you should remember one important clue for this. What is that? Fraction of A minus 3 will be highest, okay, when this particular thing will be maximum when H3A, okay, tribasic acid, that is with 3 hydrogens, isn't it, right? An acid which tribasic, that is H3. So this particular H3A has to completely neutralize into solution. So first important thing is this value will be highest when H3A is completely neutralized. okay, completely neutralized. And the solution, and once it is neutralized, whichever solution has the highest pH, okay, this is the pH value on the x-axis and this is a fraction, done. Okay, whichever has highest pH, that that would be the point of that particular, that line represents A minus 3. Once again, I'm telling you the solution which has highest pH. Okay, let me write what I'm telling. Solution which has highest pH, and that is a point for that line represents, that line represents, okay, this in A minus 3. So now let us come back and see. So this is the fraction of the solution which is given to us. Now when I have to say pH, when I move towards that extreme, here the 0, minus 2, minus 4, so which is maximum, which solution has maximum? This has maximum value, isn't it? So line A or the point A, hence point A, this point A represents the line for A minus 3. So the option is A. This is the correct option. Done. Right. So remember this, highest pH, then only you can say that it's completely neutralized. Done. Next question. Question number 5. What do they give me? They've given me benzene and its derivatives undergo electrophilic substitution reactions. Okay, done. They have given benzene and its derivatives. In one benzene ring there is amine group, one more it is, they have nitro group. Identify P1 and P2 in the given energy level diagram. Done. They've given a diagram where there are two graphs. One is P1 and P2. Now what did they give me? They've given me 4 different options. In that benzene, the benzene has amine group and E, activating substituent. Here amine group, and again they have activating substituent E. Again they have amine. So different positions, right? So here they have para positions. Here you have one meta position. Again here para, and option again is meta here and para here. Here nitro group with para position and nitro group and an activating substituent in the meta group. Different combinations and none of the above. So first of all, when such question is given to you, what should you remember? You need to remember the nature of amine as well as nature of nitro group, right? So what is the nature of amine? Amine group is activating group, correct? Right. So and lower energy path is only for para substituent. Your first important thing you have to remember is amine group is activating group and lower energy path. Lower energy path. There are two paths, isn't it? This is path 1, this is path 2. Lower energy path is for para substituents. Remember that. Yes. Now let us come back and see next one. Next is which group? Nitro group. I should speak about nitro group also. So nitro group is which type of group compared to amine? Nitro group is a deactivating group. So you can write that Na2 group is deactivating in nature, right? So when it is deactivating group, what should you remember? And at what point? Here we said amine group is activating and it lowers the energy at para position. So I have to find amine group is activating. Where is that thing present? It's present in para position. Okay, para position, done. And lowers the energy, the path for para substituent. Para substituent, that's it. Okay, the next one, nitro is deactivating, I said, and it lowers energy path for meta substituent. This is the concept. Now let us see which one is this. So I said para nitro group, I said, isn't it? So I should see the combination, right? First one, no, but the second one, I think this is a small correction here. This should be NH2. Correct? Yes. This is NH2. I'm sorry for that. This is NH2. This is NO2. Now see. So amine group is activating and lowers the energy path for para substituent. So this is the combination. See here, this is para. This is also para. I can go for this. But important thing, nitro group is deactivating and lowers energy for meta substituent. But this is not meta substituent, isn't it? This is meta, but this is not nitro. So the combination is amine group at para, nitro group at meta. So such combination is what it represents the graph. So the correct option is C. Done? Yes. So remember this. Hope it is clear with both the explanations, and let me come back and do the next question. So what is the next question? Here they've given us one more graph. So for a first order of the reaction, they've given us first order rate equation for this graph. For the first order reaction, they've picked up 4 different graphs, right? So in this particular thing, what did they give me? This first order reaction, the form is A forming products. Okay, yes. So in this A forming products, the correct representations are, they've given this. So what should I do? I need to, they've given different graphs. First one, A by A naught, okay, versus time, they've given different concentrations. Here also they've taken in A by A, the fraction of this versus time, they've given different constants. They're asking you which is right? So let us first solve it. I need to solve and then come back to the options. For solving this question, let me take, first of all, they have said first order kinetics. From the first order kinetics, what the formula is, ln A by ln A naught is equal to minus KT. This is what you have studied. Yes, that means, what does it show? It shows that ln A by A naught decreases linearly. Correct? It decreases linearly with time. This is what is that, minus is given, right? So with time. Done. So what is, how can this be written? This can be written as ln by A naught is equal to minus KT equal to A by A naught is equal to minus by E KT. I can write this like this also. Yes. So this equation shows that, what does this equation show? The ratio of A by A naught will decrease, right? It will decrease with increase in time. This ratio will decrease with increase in time, but exponentially. So let us write that also. According to this formula, ratio of A by A naught will decrease with, this will decrease with increase in time. Yes, will decrease with increase in time exponentially. This is what is important, right? So this is the concept according to the graph. Now let us come back and see the option. So when I have to see the option, yes, so which is decreasing, which increasing, right? So over here, look here, time will decrease. Okay, we said if this is increasing, the time has to decrease. Or if the time is decreasing, this has to increase. So this is what is the concept, isn't it? Now in other cases, if I have to see, it is not the other way, the other way. So the correct option for this is A, right? So done. Let me come back and do the next question. So in this next question, they've given us titration graph, one volumetric graph they've given us. So let's see this. So they've given here, consider the given titration curve. Okay, and in this titration curve, they've given the values of volume of titrant added from the burette and that thing, or concentration of the solution here. What was the original concentration of the solution if the original volume was 100 ml and it was titrated with standard solution in the burette and that had a concentration of 0.1 molar? Okay, right. So first of all, what concept you should remember? The originals, what is the original solution? First you should know. So the original solution, when I have to see the pH value, this is the pH values, isn't it? Right. If I have to see the pH value, right, the pH value for this is greater than this of H plus, isn't it? Molar concentration of H plus used up, isn't it? Because it is more than 10. Fine. So that means it is basic in nature. So first important concept you have to remember is original solution is basic. Seeing this thing is basic. Why? The initial pH also, if I have to see, initial pH is greater than mole of H plus. Okay, this is done. Yes. Now, how much is used up? Here when I have to say completed, this is the end point, isn't it, which they were titrated. How much is used up? 250 ml is used up. Yes, when 250 ml is used up, how much was the concentration that thing? Just 0.1, isn't it? And I have to see, because the original concentration 100 ml was titrated, they said. So it is 250 into 0.1. It is equal to 25. Okay, this is 25 moles per 400. Right. Now, initial molarity of OH, how should I find out? Because they asked me to find out how much is this. So, initial molarity of OH minus is equal to 25 by 100, because 100 ml was titrated. They said it was, they said the original volume was 100 ml. It was titrated with a standard solution. 25, which is equal to 0.25 molar. Let's come back and do the 8th question. So first of all, what did they give us? They've given us a rate equation in chemical kinetics question. So I've just written the question only here again. Let me read. In the reaction P plus Q gives R plus S, the time taken for 75% reaction of P is twice the time taken for 50% reaction of P. Okay, right. The concentration of Q varies with the reaction. What? So they've given one condition for P and they want us to find out for Q based on that, right? Now they've given us a graph. Q, the concentration of Q, initial concentration here is given, and versus time. So first I've written what is given here. Time of 75% reaction is twice the time taken for 50% reaction, right? What is this thing? It is according to first order, isn't it? With respect to first order, right? So let me start. Now, from the graph, when I have to take concentration of Q, it linearly decreases with time. This is what is shown, right? But this graph, this is according to the first order, but this is according to the 0th order, isn't it? Yes. So what do we observe from the graph? Okay, concentration of Q decreases linearly with respect to Q. Correct? Yes. So this is 0 order reaction. 0th order. Okay. Right. So now, how can I write? dx by dt is equal to K P raised to the power of A, because the coefficient we are taking it in that way because they will not mention anything there in the reaction. So raised to A, Q raised to the power of B. Right. So order with respect to P is what? Is equal to A, which is equal to 1. Right. Order with respect to Q is B, which is with respect to 0, because it is 0 order reaction, we said, isn't it? Yes. According to the graph, it is 0th order reaction. Respect to this one was first order reaction with the condition 0 order reaction 0. So what is the value when I have to say A is equal to overall order of the reaction? What is the overall order of the reaction? If I have to see the answer, overall order of the reaction is 1, isn't it? Because for this one P we have taken 1 and Q we have taken 0. So the correct answer is D, that is 1.